Hello everyone. This tutorial video is about how to calculate your sample size based on a proper power analysis. So I think you probably are mostly familiar with the G-Power application or software that's typically used for this purpose. So when you have a regression-based mediation analysis, you typically have two options to do your power analysis and calculate the required sample size. One is the G-Power that is easy also. I mean, it's simpler to work with and easy to understand the results. And another way is Monte Carlo simulation method that is a little bit more complex, but also it's not very hard to use. And also I will provide enough guidance how to use each of them or how to report the results if you want to use any of them. And I would say that the GPower is easier to use, but Monte Carlo is more complex, but it is more accepted, because there's a more sophisticated way of power analysis for mediation analysis. So let's start with GPower. So why we are using GPower? GPower actually does not have a very specific power analysis for mediation analysis, but we still can use GPower because mediation analysis is basically based on two regression models. So it's not something separate from regression analysis, especially when you are doing that based on a cross-sectional and correlational design, and we don't want to claim any causality. So in that case, many aspects, many assumptions, or many aspects of a statistical analysis and research design that applies to regression analysis will apply to mediation analysis as well. That's why in the same way that we calculate power for a regression analysis, we can calculate power for mediation analysis as well, based on the rationale that we are using the mediation analysis with similar approach as a regression analysis. But if you want to do mediation analysis like within the context of an experimental study, like manipulating your IV and also and concluding some causal effects, in that case, G-Power may not be a good option to consider. So anyway, if you want to use G-Power, it's definitely fine. I mean, you don't have to go to the more complex ways, and it's acceptable for me and will be acceptable for, I mean, most of the reviewers or academics also will accept that for mediation analysis, especially when you clarify that your approach is a regression-based mediation analysis. So for going to GPower, you start to clarify your test family. Because you are going to do your analysis based on regression-based, you go to F-test family. And here you have a few options that you can choose. That two options are okay, and both of them can be justified and proper approaches to your power analysis. One is linear multiple regression based on fixed model R-squared deviation from zero, and another one, linear multiple regression fixed model R-squared increase. So what's the difference between these two? I think you can understand the difference if you watch this video actually after my other tutorial video about the general concept of mediation analysis. But in summary, this one actually, you can choose this one and it's appropriate based on this rationale that in your mediation analysis, it's actually basically based on like the maximum number of predictors that you usually have in your mediation analysis is two predictors, that is your IV and your mediator, that together they predict in your DV. So in this case, you consider them as two parallel mediator that you want to see if they can predict significantly your IV. That means deviation from zero. But R-squared increase, that means that actually you can also use this one because mediation analysis actually is not based on simple regression analysis, it's based on some controlled regression analysis. That means that, for example, in some steps of your mediation analysis, we are interested to see if your mediator can predict your DV with controlling the effect of IV, like above and beyond the effect of IV. And in the other step, you want to see if your IV can predict your DV above and beyond the effect of mediators. So based on that rationale also, you can choose these ones. But both are okay. I mean, I don't go too much in statistical details. And you can see that the difference won't be that much. So let's see with the simple one, that is deviation from zero. When you choose this one, that you can see that it's an a priori power analysis. And we can also mention these aspects in your method section. Like you can say that you use a priori using like alpha equal to 0.05. And like you mentioned also, and you can see a good sample like in the ethics document that I used actually this approach and refer to this statistics. So F squared is by default 0.15 that represents a medium effects. However, if for your specific studies, you check the previous similar studies and you notice that the effect sizes that they are representing is not medium, like for example, it can be a small effect size, then you may consider a lower amount of F squared, like 0.2, for example, can be for a small effect, so a little bit higher than that. So this our decision about this is based on our previous similar research that either we have done that or based on previous similar published research, and we check that the level of the effect sizes that they reported for similar relationship, like based on the relationship between our IV and our DVs. One similar study has reported like a medium effect size. So it's okay, we remain with medium effect size here. So actually, it's the previous studies that inform us how to determine the level of our effect size here. But we usually consider medium or a small effect size. Or if there is absolutely no previous research, we may be a bit conservative, consider something between a small and medium effect size, not fully medium. And we usually for alpha, we consider it's like p-value, we consider that 0.0.5. But for power, 95.95 is too much. 80 would be enough, like 80% would be more than enough for like a good power that you want to consider. And number of predictor I consider here too. Why? Because I just have IV and mediator that are going to predict dependent variable dV. However, if I want to include covariates in my study, I will increase this number because the covariate also can be considered treated as another predictor. So let's see if I don't have any covariate and I want to calculate my power. So let's see what happened here. So here you can see that this one is important, about total sample size. So based on the information I provided with a medium effect size, alpha 0.05 and power of 0.80, and two predictors, my result suggests that a minimum of 68 participants potentially can be enough that if I have a genuinely significant effect, it can be detected by a minimum of 68 participants. However, if I, like coming back to this, if I have instead of two predictors, I have also covariates. So for example, imagine I want to include gender as a covariate. So I add three predictors here. And let's see what happens. So, but actually for covariates, if you have covariates, I would suggest that you try another approach, that not deviation from zero, that was this one, like increase. But anyway, here also I just wanted to see that how it's differentiated more than two predictor, that you can see that the number now is more because you had another predictor. So, but if you want to go for actually having covariates or want to be a little bit more conservative, so you can choose this one. So, I mean, even if you don't have covariate, this one also is commonly used for mediation analysis, so that you, instead of deviation from zero, you consider that increase. So sort of they are both common approaches, and there is not a lot of difference in the outcomes that you have. So let's now try with this one. What I would suggest, if you want to include covariates and do power analysis with considering covariates, I would suggest this increase approach would be more appropriate, because when you include covariates, your regression analysis would be like a hierarchical regression. And for hierarchical regression, we specifically come to this method of analysis. So again, I would consider, like, for example, a medium effects. I would consider like my alpha is okay. I just change it to 80. And here, when it asks you number of tested predictor, we usually consider one, because at each step of our mediation analysis, we just want to see, for example, how mediator is predicting DV with controlling the other variables, either covariates or DV, or how the IV is predicting DV with controlling mediator and covariates. And here are a number of other predictors. A total number of predictors, like all together. So for example, if I have one covariate, I have one IV, one mediator, and one covariate. In general, I have three predictors. Two of them is my IV and mediator, and one additional one as covariates. And let's see what it suggests here. So here you can see that even with considering that I have another covariate as well, still with 55, I can have a better sample size. So this approach actually is less strict than the other approach. That we can see that there, even with three predictors, we have like 77 sample size, if I can remember correctly. But here it's suggested lower than that. But still, the difference is not very significant here. So that's all we have. And you know that this is just about the minimum of suggestions, but in general, we actually should have our actual sample size much above what we can see in the results of power analysis. So this one was about how to use G-power. So this is a very valid calculator. It's a valid statistical website that will run Monte Carlo simulation for power analysis of mediation analysis for you. Otherwise, there are some other apps like R package that you can use for that, but you don't have to. That is completely a valid approach, that you use a valid online calculator for Monte Carlo simulations. So there are a lot of concepts here that is really too complex to explain, and you don't have to care about that. I'll just simply show you what you need to input here and what you need to report actually in your power analysis. So this is very simple. You start actually to specifying the minimum sample size that you want to consider for a study and maximum sample size that you want to consider. So by default, is a 50 and 500. That's actually very suitable for our study because we also expect that we may have around 400 ideally, or about 400 participants we may have with a minimum of 370. So that would be not bad actually to leave it as it is. And but alternatively, you can reduce the maximum like to 400 or something like that if you like. But the minimum 50 is good. And then the intervals also is good. It's recommended to keep the interval at 10. I mean, it's a very difficult statistical explanation why, but just I would say just leave it as default for this. And so path A, path B, path C prime. If you have watched the other video about the general concepts of a mediation model and the paths in a mediation model, so you should be already familiar what does it mean. But if not, if I want to briefly explain that, path A is actually the standardized effect of your IV on your mediator. Path B is the standardized effect of your mediator on your DV, and path C prime is the standardized effect of your IV on your DV when it's accounted for the effects of mediator on DV. So this part asking you that what you expect about the level of your effect size. So by default, there are medium effects for path A and path B, and path C prime is not determined. So I did it myself here. I just filled it myself here. So 39 is actually a medium effect for the standardized direct effect that we explained. That you can see, I mean, in the group supervision and also in the other tutorials why it can be a medium, but I will explain that later. But based on the effect sizes that we have in mediation analysis, 0.31 can be a medium effect. Like around, you can reduce that like for 0.15 or something like that. That can be a small effect. If you expect that, you will have a small effect. Again, past research can tell you that what you would estimate or suggest for the level of your effect size is very much similar to the level of effect sizes that you estimated in G-Power, but here the metric of the effect size is different. It's about beta. It's not about F squared. So, and for beta, 0.39 is a medium effect that you know is different from the F squared that 0.15 was a medium effect. So I consider that, I assume that based on processor, I can assume my path A, I can expect a medium effect. For my path B, I can expect a medium effect. And for my path C prime, also I can expect a medium effect. So I put it like this. And I would suggest leave it also as default, like path A, path B, because it includes the answer specification for both of your paths in your mediation analysis, and all of your variables can be included in the assumption. So I would suggest not changing that if it is like this, path A, path B. So odds actually, when you consider one versus one, is a very unbiased approach. That actually the best one, that it shows that you are telling that I don't extremely impose my expectations that there is a high possibility of having a significant mediation effect. I'm just telling that I 50-50, like 50% maybe there is a significant mediation effect, and 50% maybe there is not a significant mediation effect. So I would say that leave it at one versus one for this as well. That's not having any bias for your expectation. And the significant level also can be 0.5. And again, power is very similar to G-power setting that you consider 0.8. So number of simulation, the 1000 is the default and the lowest number. But the recommendation is that for a simulation, for more robust simulation, if you put it in 5,000 or 10,000, that would be better. That would be more robust approach. But if you do so, if you do calculate, it takes several minutes to complete your calculation, but it deserves waiting because you get a more robust calculation. But here I just put it in 1000 to save time. And you don't need to change this, just the other thing, just leave it as it. And if you want to change 1,000 to 5,000 or to 10,000, one of these two options, you can do that. So when you click on calculator, I had done it before this recording, so that's why you see that here. But when you, for the first time, click on calculate, it may take several minutes that it gives you here. And the website does not show you any processing symbol, so you cannot, you may think that it doesn't do anything, but actually the website is calculating. So don't close the window and wait for a maximum of 5 minutes, and then you can see that it will appear here, the results. So in the results section, what you're interested in, I mean, there are a lot of weird and complex that you don't have to care about. What you're interested is the n that you can hear, that the initial n, that is like 50, and the final n, that the n that is the simulation stopped actually, and gives you that, consider that's the final sample size that you can consider. So here, for example, if I had a smaller effect sizes, it might not stop, they wouldn't be the same. It might go to 50, it might go to 100, 150, and then, for example, stop at 150. But because I suggested a good level of effect sizes, so it suggested to me that my initial minimum sample size that was 50 was actually strong enough to detect a good power size, like a power above 80 that here is important at the level of alpha of 0.5. I could expect a power over 80, that is 80%, that actually is very good. With just a sample of 50, like the very minimum sample that I included that. So the end that you see here actually is the final suggestion of this Monte Carlo simulation that telling you this is the enough sample size. It may not be always equal to the initial minimum sample size, but here, because the effects are good and strong enough, so it suggests that with 50 also I can expect a good sample size. So you remember that G power also, when we use the increase the second approach in the G power, that also suggests it's a sample around 50 would be enough for this mediation analysis. And you see how they are aligned, actually. That's why I think that if you use G power also, that's not a wrong approach. It's usually not very different when you use the same power analysis with other approach. And you know that G power even suggested a higher sample size that was even more conservative when we considered actually the first approach in G power. So, so that's why it's not wrong to use GPAB. And I will explain more like how to refer to that in your method section and how to report it and what aspects of this table or the GPAB table you need to report. So don't worry about that. It just was about how to calculate that. I hope it was clear, and please reach out if you have any questions about that.